Welcome dear students to another very important topic of the chapter chemical bonding, and that is the Lewis electron dot structures. My dear students, Lewis electron dot structures are basically those structures of a molecule which show the bonding in a molecule in terms of the number of shared pair of electrons, number of lone pair of electrons, number of single and multiple bonds. Lewis electron dot structures, no doubt, they provide the idea of the bonding in a molecule, but looking at the Lewis electron dot structure, you will never be able to decide the overall behavior or chemical reactivity of a molecule. But still, the idea of bonding that becomes clear by looking at the Lewis electron dot structure. While you will be writing down the Lewis electron dot structure of any molecule, keep one thing in your mind that this Lewis electron dot structure is based on the octet rule, means every atom in a molecule should get 8 electrons in its valence shell except hydrogen, for which the duplet rule is applied. Now, how to write down the Lewis electron dot structures? What are the steps? The first step is that first of all calculate the total number of valence electrons in a molecule by simply adding the number of valence electrons in each atom. If you are dealing with an ion, the ion may be a negative ion. You know, negative ions, they have extra electrons, and cations, they have basically deficiency of the electrons. So if you are dealing with a negative ion, then you will add the number of electrons to the total number of valence electrons, and that addition of electrons should be equal to the negative charge on that anion. If an anion has negative charge of -2, then 2 electrons will be added to the valence electrons. If it has charge -3, 3 electrons will be added, and so on, because anion is electron rich. So it has some extra electrons which will be added in the total number of valence electrons. In case of cation, if a cation has +1 charge, then it means it is 1 electron deficient. So after calculating the number of valence electron, you will subtract 1 electron from that total number of electrons to show the deficiency of 1 electron. If the cation has charge +2, then 2 electrons will be subtracted. If it has charge +3, then 3 electrons will be subtracted to show the deficiency of electrons. After counting the number of valence electron for a molecule or an ion, then you will write down its skeletal structure. Skeletal structure is based on the symbols of the atoms and the geometry of the molecule. If you have an idea of the geometry of the molecule, then you will be able to write down the skeletal structure in a better manner. After writing the skeletal structure, now join the atoms through single bonds, and then after joining through single bonds, now complete the octet by using the total number of valence electrons in the form of the lone pairs, in the form of the multiple bonds. The condition is that every atom should have 8 electrons in its valence shell. Then that will be considered as the correct Lewis electron dot structure. How these steps are performed, let us look into some examples. The first example is fluoramine NF3. The step 1 is to calculate the total number of valence electron. Nitrogen is a member of group 5A, so it has 5 valence electron. Fluorine is a member of halogens, it is 7A, so it must have 7 valence electrons. And total valence electrons should be equal to 5 of nitrogen, 7 for 1 fluorine, and for 3 fluorine you will multiply it with 3. That will be equal to 5 plus 7 into 3, 21. 26 valence electrons are there. After calculating the total number of valence electron, now write down the skeletal structure. Nitrogen is the central atom. Usually those atoms that are less electronegativity, they are considered as the central atom. And there are 3 fluorine which will be terminal or peripheral atoms. So that is the skeletal structure. Now join the atoms through single bonds. After joining the atoms through single bonds, you know, one single bond means one pair of electrons. So show that bonding pair. So 6 of the 26 valence electrons are used in bonding. Now there are remaining 20 electrons that will be distributed between the atoms to complete their octet. This fluorine has two electrons, so in order to complete its octet, it must have six more electrons in the form of three lone pair. So 1, 2, 3, 4, 5, 6, 7, 8. Its 8 electrons are completed. In the same manner, every fluorine will get three lone pair of electrons for the completion of its octet. 1, 2, 3, 4, 5, 6, 7, 8. In this way, octet of all fluorine atoms is completed. Now, if the octet of all three fluorine atoms is completed, it simply means if this fluorine has 8 electrons, it is also having 8, it is also having 8. So 24 electrons are used to complete the octet of three fluorine atoms. How many total valence electrons are there? 26. It means we have just two valence electrons left, which will be used to complete the octet of the nitrogen. Now let us look into the nitrogen. In this case, nitrogen has 1, 2, 3, 4, 5, 6 electrons. In order to complete its octet, the remaining 2 electrons will be given to nitrogen, and thus its octet will be completed. My dear students, its dot structure can be written as something like that. There are three bond pair of electrons. Every fluorine has three lone pair of electrons, and this nitrogen has one lone pair of electron. So that is the overall Lewis electron dot structure of NF3. Its geometry should be something like nitrogen has one lone pair and it has bonds with three fluorine. So overall electronic geometry will be tetrahedral. That is about NF3. Now let us look into the second example. The second example is very important because the second example will also give you the concept of the formal charge and resonance structures, and that is an anion NO2 minus 1. Again, nitrogen is a member of group 5, so it has 5 valence electrons. Oxygen, member of group 6, has 6 valence electrons. Total valence electrons 5 for nitrogen, 6 for one oxygen. There are 2 oxygen multiplied by 2, and it is an anion. It should have extra electrons equal to the charge on that anion. It has minus 1 charge, so it will be having 1 extra electron in the valence shell. 5 plus 12, 17 plus 1, 18. So it has total 18 valence electrons. Now let us write down the skeletal structure N, O, and O. Join them through single bond, the next step. Now show the bonding pair of electrons 1 and 2. So out of 18 electrons, the 4 electrons are used in bonding. Now we have remaining 14 electrons which will be used to complete the octet of all the atoms. Oxygen has 2 electrons, so to complete its octet, it must have 6 more electrons in the form of 3 lone pairs. Similarly, this oxygen also has 3 lone pair of electrons. So octet of both oxygen is completed. If octet of both oxygen is completed, it means 8 plus 8, 16 electrons are used. Now we have remaining just 2 electrons. Now let us look into the nitrogen. It has 1, 2, 3, 4 electrons. If you will give remaining 2 electrons to nitrogen, still it will be having 6 electrons in its valence shell and its octet is not completed. So by using the single bonds and lone pairs, the octet is not completed. Now the next one is that you will have to change the single bond into multiple bonds. This oxygen will use one of its lone pair to form another bond with nitrogen here. And now the case will be N double bond O, single bond oxygen. Let us place the electrons. Now there will be 2 bond pairs as it is double bond and it will be having now two lone pair of electrons, as one lone pair is used to construct a bond here. Nitrogen has one lone pair of electrons. This oxygen has three lone pair of electrons, and one bond pair is there. In this way, now nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So octet of nitrogen is also completed. And the overall charge on this anion, that should be -1. But my dear students, this oxygen uses its lone pair. It is not necessary that every time this oxygen will be using its lone pair. There are equal chances that this oxygen may also use its lone pair. So the second case is, if this oxygen uses its lone pair to construct a bond instead of this oxygen, then the structure should be N double bond O, single bond O. Again, the electrons should be 2. Two bond pairs, it will be having no only two lone pair of electrons, just like this oxygen, and it will be having no 3. Nitrogen will be having 1. So that one is another possibility in this structure. Overall charge, again, that will be -1. Now, my dear students, these are two structures, structure 1 and structure 2, which have equal number of atoms, which have equal number of bonds, which have equal number of total electrons, but the difference is in the arrangement of the bonds. Here, this oxygen has single and this one has double bond, but in this case, this oxygen has double and the other has single bond. So these structures which have same number of atoms, same arrangement of the atoms and nuclei, same total number of valence electrons, but different bonding arrangement, they are called as the resonance structures, shown with double-headed arrow. So these are two resonance structures, or you can say these are two canonical forms or canonical structures of NO2 -1. The real structure will be obviously hybrid of these two structures. It will not be having single or double bond. Rather, the bond will be stronger than single bond but weaker than double bond. Its bond order will be 1.5. And overall, there will be -1 charge. So this structure will be called as the resonance hybrid, which is more stable than its canonical forms due to its lower energy. And its lower energy is due to the phenomenon of the resonance. My dear students, let us now find the formal charge. Dear students, formal charge is equal to, listen very carefully, it is equal to number of valence electron minus number of electrons that an atom has in its Lewis structure. To calculate the formal charge of this oxygen, its valence electrons are 6 minus. How many electrons it has in this Lewis dot structure? It has 1, 2, 3, 4, 5, 6. These two electrons are shared by nitrogen. While calculating the formal charge, you will consider only those electrons of an atom that are shared by that atom. Those electrons which are shared by some other atom, they will not be included while calculating the formal charge. So 6 minus 6, formal charge of this oxygen will be 0. Now let us calculate the formal charge of this oxygen. It has 6 electrons in its valence shell minus how many electrons are given to this oxygen in this dot structure? 1, 2, 3, 4, 5, 6, 7. So it will be having -1 formal charge. It has 0 formal charge. Now what's about the nitrogen? Nitrogen belongs to group 5. It has 5 valence electrons minus 1, 2, 3, 4, 5. The 5 electrons are given to nitrogen in this Lewis structure. So its formal charge is 0. Formal charges are basically the charges on the individual atoms. This oxygen will be having formal charge -1. This one will be having 0. Nitrogen will be having 0. But the overall real charge on this NO2, that will be -1. Formal charges are just the fake charges, calculated charges. But the real charge, that is the overall charge on the ion, and that will be -1. So in this way, the concept of resonance and formal charges is also discussed here. Now let us look into the last example, which is a cation, NH4 plus 1. Again, nitrogen has 5 electrons, and hydrogen, member of group 1, it has 1 valence electron. Total valence electron will be 5 plus 1 hydrogen has 1 electron, so 4 will be having 4. But it is a cation. It means it is electron deficient. And the charge on cation shows how much electron deficiency it has. It has a charge plus 1. It means it is 1 electron deficient. So here will be minus 1. 5 plus 4, 9, minus 1, 8. So it has 8 valence electrons. After calculating valence electron, write down the skeletal structure N, H, H. Now, my dear students, join these atoms through single bonds and then show the number of bond pairs 1, 2, 3, and 4 bond pairs. Duplet of all hydrogens is completed. It has 2 electrons, 2, 2, and 2. Hydrogens, their duplet is complete. What's about the nitrogen? Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Octet is also completed. So that was very simple actually. N, H, 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 and H. Now you will just show the one pair of electron between nitrogen and hydrogen in all cases, and overall charge will be plus 1, and this overall charge plus 1 is due to nitrogen. How? Let us calculate its formal charge. Nitrogen belongs to group 5, so it has 5 valence electron minus 1, 2, 3, 4. It is given 4 electrons in this Lewis dot structure. So it will be having plus 1. This nitrogen will be having plus 1 formal charge, and all hydrogens, they will be having 0 formal charge. So overall real charge on this ammonium ion will be plus 1. And its geometry will be, obviously that will be tetrahedral. Overall geometry will be tetrahedral. So in this way, you can write down the Lewis electron dot structure of any neutral molecule, any anion or any cation. Practice some more at your home, and if you find any problem, any query, do ask me in the comment section. I will answer that. Till then, take care.